my dear students. Let's start the session.
Plane motion. Right on? Plane motion. Today we are going to start a new topic, that is plane motion. First we can talk about pure translation. Pure translation. Put it in. Pure translation. Pure translation. In pure translation, first we can talk about kinematics. After that, how to apply dynamics. How to apply dynamics. See this. In pure translation, velocity at any point on the disk is same and it is acting and it is in the direction of motion of the disk. Right on? In pure translation, first kinematics. Right on? In pure translation. In pure translation. In pure translation. Velocity at any point on the disk is same. Velocity at any point on the disk is same. Velocity at any point on the disk is same. Any point on the disk is same, and it is in the direction of motion of the disk. Any, underline any. Okay, so any point on the disk is same, and it is in the direction of motion of the disk. In the direction of motion of the disk. In the direction of motion of the disk. Clear? In the direction of motion of the disk. So if the disk is in pure translation, this is plane motion. Pure translation. See here, it is in pure translation. It is moving with the velocity v, linear velocity v. After time t seconds, it will go to here. So it is moving velocity in pure translation. కొద్దిగా పెద్దగా గీసుకోండి. This is the pure translation. In pure translation, velocity at any point on the disk is same. This is the center. This would be A. This is B. This is C. This would be point P. So now we can take the velocity here. This is the velocity here, V. Velocity here, V. Velocity V. And the point Q. Here you can take point I, point P. What is the velocity at this point? Velocity at any point on the disk is same, and it is in the direction of motion of the disk. Clear? So in pure translation, like that. This is solid body, rigid body. Clear? Disk, solid disk. Velocity at any point on the disk is same. And it is in the direction of motion of the disk. So here we covered the magnitude and direction. What is the magnitude? Same. That is what? Any point on the disk is same. This statement refers to the magnitude. This statement refers to the direction. Okay, now direction of motion of the disk. Now coming to pure rotation. Pure rotation. Coming to pure rotation. In pure rotation, velocity at in pure rotation, velocity at any point on the disk is okay na, product of, this is the magnitude of rotating component of velocity, product of angular velocity of the disk, product of angular velocity of the disk, and distance between the at a given point, at any point in pure rotation, velocity at any point on the disk, product of angular velocity and distance between the given point, and center of rotation of the disk, This is the magnitude product of angular velocity of the disk and distance between the given point and center of rotation of the disk. Clear? And what is the direction? And it is in tangential, in the direction of tangential to the disk. In the direction of tangential to the disk. Clear? Velocity at any point on the disk. What is the definition of velocity? Rotating component of velocity is this. And it is in the same sense of omega. What is the meaning of sense? See here. So this is omega, angular velocity of the disk. Radius of the disk is capital R. Center of rotation O. Okay now. So here, what is the velocity at point A? Velocity at point A, velocity at point B, velocity at point C, velocity at point I, Clear? So in the same sense of omega and tangential to the disk, this is the tangential to the disk, acting tangential to the disk. Tangential means perpendicular to the radial line. In the same sense of omega, this is the sense of omega. This is clockwise sense. This is also acting in clockwise. Clockwise means towards right. So now tell me, what is the velocity at point C? Pure rotation. Omega R. Product of angular velocity of the disk and distance between the given point C and center of rotation. Omega R. What is the velocity at point B? Omega R. Velocity at point I. Omega R. This is velocity at point A. Omega R. So what is the velocity at this point smaller? So in the same sense of omega, this is how much? At this point B. What is the velocity at point Q. At this point P, this is the velocity at point P, R omega. Velocity at point Q, this is small r omega. Velocity at point Q, small r omega. Understood? So here, what is the angular velocity? Omega. Omega is the angular velocity. If you take arc length x, how you got it? Arc length x, this is r theta. This is r theta. So here, x bar equivalents to r theta bar. Okay na? So if you take dx bar by dt bar, dx bar by dt, dx bar by dt, that equivalents to, ಈಗ ಮಲ್ಲ ವೆಕ್ಟರ್ಸ್ నేను ಸಪರೇಟ್ గా చెప్తా, dx by dt equal to r d theta by dt. So we can write it as dx by dt is the rotating component of velocity into r omega. X equal to r theta, v equal to r omega. This is the magnitude. So pure rotation, in pure rotation, velocity at any point on the disk is product of angular velocity of the disk and distance between the given point and center of rotation of the disk. In pure translation, velocity at any point on the disk is same and it is in the direction of motion of the disk. Now coming to the pure rolling. Rolling is the combination of both rotation and translation. Pure rolling. When you can call the rolling as a pure rolling. Here you can write pure rolling, plane motion. Pure rolling. Rolling at no slip condition is called pure rolling. First, what is meant by rolling? Clear? So, what is rolling? Rolling is the combination of both rotation and translation. What is the pure rolling? Pure rolling is the rolling at no slip condition. Pure rolling is the rolling at no slip condition. What is the no slip condition? Chapandi, what is the no slip condition? Velocity at point of contact 0. Velocity at point of contact is 0. This is the combination of both rotation and translation. So now we need to talk about rolling. See here, combination of both rotation and translation. Nothing but. So here, it is having linear velocity v and angular velocity omega. Plane, it is rolling. V, angular velocity omega. It is having both the translating component of velocity, so-called linear velocity, and the rotating component of velocity. See here. So in this case, this is the pure rolling. Here to here, we need to talk about A. This is B. This should be C. This should be I. Clear? So ఇప్పుడు మనం ఏం చేయాలి? What is the? Now we need to draw some big figure in order to represent all component of velocities. See here, this is the center O. Center O. Center O. Here to here. This is A. This would be B. This would be B. This would be C. Here to here. This is P. P. This is I. I. Clear? First represent linear velocity. Linear velocity. What is the linear velocity at point C? Linear velocity at point C. V is the linear velocity. What is the linear velocity here? V. Here, what is the linear velocity? V. Velocity at any point on the disk is same, and it is in the direction of motion of the disk. In the direction of motion of the disk. Here also, this is V. This is V. Velocity at any point on the disk is same, and it is in the direction of motion of the disk. Now coming to rotating component of velocity. Rotating velocity. So it acting tangential to the disk and in the same sense of omega. And in the same sense of omega. So called omega R. This is R. Okay na? So we can take small r or capital R. Doesn't matter. So in the same sense, in the tangential omega R. This would be omega R. Omega R tangential to the disk. In the same sense of omega. Tangential to the disk. In the same sense of omega. In the same sense of omega. Tangential to the disk. In the same sense of omega. Tangential to the disk. In the same sense of omega. Clear? Now, what is the no slip condition? No slip condition. Yet no slip condition. No slip condition. Velocity at point of contact 0. That means what? Vi equal to 0. Vi equal to 0. Then we can call these two components of velocities are equal. Then only velocity at point of contact 0. Yet no slip condition. V equivalents to how much? Yet no slip condition. V equivalents to how much? Omega. V equivalents to how much? Omega. V equivalents to how much? Omega. Understood? Rolling is the combination of both rotation and translation. Rolling at no slip condition is called pure rolling. What is the no slip condition? Velocity at point of contact equal to 0. Velocity at point of contact equal to 0. V equal to omega. V is the linear velocity. Clear? Clear. Now, what is the velocity at any point on the disk? What is the velocity at any point on the disk? Here we can take what is the velocity at point A. Velocity at point A. Velocity at point B. Velocity at point B. Clear? So this is the velocity at point B. Velocity at point B. So now we can say, see this. What is the velocity at point A and point B and point C? So here we can take table. Take table. Here, what is the velocity at point A? చూడండి ఇక్కడ what is the velocity at point A? Velocity at point A. Velocity at point A equal to how much? Square root of v square plus omega r whole square. V square plus omega r whole square. We know that v equal to omega r. If you substitute v equal to omega r, Va equal to how much? Root 2 V will come. Understood? V square plus V square, 2V square root 2V. What is the velocity at point B? What is the velocity at point B? Velocity at point B. That is also apply parallelogram law of vectors. Angle between them is how much? 90 degrees. Angle between them is how much? 90 degrees. Cos 90 0. Cos 90 0. Then what is the velocity at point B? Velocity at point B, tell me. V square plus omega r whole square. That equal to how much? Root 2v. Root 2v. So now tell me. Vc equal to how much? What is the velocity at point C? Velocity at point C, tell me. Both are same direction. I cap plus I cap. Understood? So what is the net velocity? V plus omega r. If you want to take, this is how much? 2 times of V. That is how much? Vi cap plus omega r I cap. V plus omega r. V equal to omega r. 2V. Velocity at point I. Velocity at point O. Velocity at the center. Velocity at the center. What is the rotating component of velocity at the center of rotation of the disk? Center of rotation of the disk. Omega into distance between the given point and center of rotation of the disk equal to 0. No rotating component of velocity at center of rotation of the disk. Then what is the velocity at point O? V. Velocity at point O. V. What is the velocity at point P? If I take 30 degrees, this will become how much? 30 degrees. This is how much? 90 degrees. What is the angle between these two vectors? 60 degrees. 60 degrees. Then we can write these two vectors. V along this direction. Omega r along this direction. Then what is the angle between them? 60 degrees. Angle between them 60 degrees. What is the resultant velocity? Net velocity. What is the velocity at point P? Velocity at point P equal to how much? Square root of parallelogram law of vectors. Parallelogram law of vectors. V square plus omega r whole square plus 2 times of V into omega r into cos 60 degrees. 60 degrees. 1 by 2. These two gets cancelled out. Then we can confidently write V equal to r omega r. V square plus 2 times of V square into 1 by 2. Understood? So here V into 1 by 2. 1 by 2. Finally 3V square root 3V. This would be root 3V. Velocity at point P equal to how much? Velocity at point P equal to how much? Root 3V. Root 3V. Clear? Understood? Next one. This is method 1. In order to calculate vector approach. So in order to calculate velocity at any point on the disk, in pure rolling only in our syllabus up to BTech level. Clear? Pure rolling only in our syllabus. Velocity at point of contact must be 0. This is kinematics of rolling. Next slide up. Method 2. How to calculate velocity at any point on the disk by using method 2. Completed. Next. Kinematics of pure rolling or rolling. So now how to calculate velocity at any point on the disk by using method 2. See here. Method 2. See here, pure rolling. We are discussing pure rolling. Here, see this. Velocity, step 1. Right up. So here to here. See this. This is okay. See here. So A, B, B, I. This is C. This would be P. This would be P. Now, write down instantaneous center method. Instantaneous center method. Instantaneous center method. Instantaneous center method. I center method. This is the instantaneous center. What is the instantaneous center? Zero velocity point. Zero velocity point. Zero velocity point is termed as zero velocity point is called as instantaneous center. By using zero velocity point, procedure to determine velocity at any point on the disk. Velocity at any point on the disk. Okay, now see here. For that, procedure to get, right now, first step 1. Procedure to get instantaneous center. Procedure to get instantaneous center. First step is mark any 2 points. Mark any 2 points on the rigid body. Mark any 2 points on the rigid body. Mark any 2 points. I am marking point A and point B. Mark any 2 points on the rigid body. Mark any 2 points on the rigid body. Now, next, draw velocity vectors. Draw velocity vectors. Velocity or represent the velocities. Draw represent the velocity vectors at those 2 points. At those 2 points, mark these 2 directions. It is pure rolling condition. Pure rolling condition. This is the O. Pure rolling condition. This is V. And this would be omega. So you know the directions. Direction of V is this. VA will come like this. You know the direction. You know the direction. What about EV? VB. This is VB. You don't know the magnitude, but you know the direction. So you have some knowledge based on this part. Here V and rotating component of velocity in this direction. Resultant of these two will be VA and VB. Okay now. Next step 2. Next step 2. Step 2. Step 2. Draw perpendicular to those 2 velocity vectors. Draw perpendiculars. Draw perpendiculars. Perpendiculars to those 2 velocity vectors. 2 velocities vectors. 2 velocity vectors. Vectors means what? You need to represent both magnitude and direction. So here only direction you know. Clear up. So here draw perpendiculars. We have drawn perpendicular. We have drawn perpendicular. So we already know that the point of intersection will be at the point of contact. This question in this case is very simple. Understood? So you know when you draw the perpendiculars, to those 2 velocity vectors, if you draw perpendicular to those 2 velocity vectors, the point of intersection will be I center. I center is nothing but 0 velocity point in pure rolling. What is the 0 velocity point? the point of contact. Okay now. So step 3 here, the point of intersection. The point of intersection of the point of intersection of the point of intersection of those, the point of intersection of those two perpendiculars is termed as instantaneous center, is termed as instantaneous center, is termed as instantaneous center, so called zero velocity point. This is the eye center, so called zero velocity point, zero velocity point, zero velocity point. This is the way to get any zero velocity point. Understood? Are you clear or not? Up to here, clear or not? Zero velocity point. How to get zero velocity point? Technically, you can call it as instantaneous center. Clear? We need to observe the motion of the body sitting at stationary position. It will give absolute velocities. That is why we are finding zero velocity point. Okay now? So we can calculate velocity at any point on the disc with reference to what? Zero velocity point. Zero velocity point is the stationary point. When you observe the motion of the body sitting at the stationary position, that relative velocity becomes what? Absolute velocity. Clear? Completed. Now tell me. Procedure to determine velocity at any point on the disc. Right now, velocity at any point on the disc is defined as the velocity at any point on the disc. Any point on the disc. Velocity at any point on the disc is defined as the angular velocity of the rigid body or disc. Angular velocity of the rigid body and disc into distance between the given point, and center of rotation of the disc. Center of rotation of the disc. Center of rotation of the disc. Distance between the given point and center of rotation of the disc. Velocity at any point on the disc. Now tell me. So this could be R. This could be R. This is R. This is R. Then tell me. This is how much? 90. Square root of R square plus R square. Root 2R. This is how much? Root 2R. This is how much? Root 2R. Root 2R. Now tell me. Procedure to determine velocity at any point on the disc. Procedure to determine velocity at any point on the disc. First I am interested in VA. That equal to how much? Angular velocity of the disc is how much? Omega into distance between the given point. Distance between the given point and instantaneous center. Distance between the given point and eye center. Distance between the given point and eye center. This is the eye. Understood? What is this? Omega into distance between the given point and instantaneous center. That equivalents to how much? Omega into what is this? IA. What is IA? Root 2R. root 2r. That equal to how much? Root 2 into omega r. We know that omega r equal to v. Root 2v. Finally, we can confidently write VA equal to how much? Root 2v. Root 2v. Same thing is obtained by vector approach. Are you clear? Now tell me, what is the velocity at point B? What is the velocity at point B? Velocity at point B. If velocity at any point on the disk is defined as the angular velocity of the distance between the given point and instantaneous center, so-called zero velocity point. So-called zero velocity point. This is how much? Omega into distance between the given point and instantaneous center. Distance between the given point and instantaneous center. Omega into IP. IP is how much? Root 2r. That equal to how much? Root 2 into omega r. That equal to how much? Root 2v. So VB also you got. VB equal to how much? VB equal to how much? Root 2v. What is the velocity at point C? Tell me. What is the velocity at point C? Angular velocity, distance between the given point and I center, that equal to how much? Omega into, this is how much? R. This is R. R plus R, 2R. R plus R, 2R. 2 into omega R, so-called 2V. So-called 2V. Then BC equal to how much? BC equal to how much is obtained? BC equal to how much is obtained? 2V. What is the velocity at point O? What is the velocity at point O? Velocity at point O. Angular velocity into distance between the given point and instantaneous center. That equal to how much? Omega into R. That equal to V. So VO equal to how much? What is VO? VO equal to how much? V. VO equal to how much? V. Now, this is how much? R. This is R. This is R. 30 degrees. 30 degrees. We need to do this construction in order to calculate IP. So, how to calculate IP? This. Here to here. How to calculate IP? This is R. This is R. See here to here. This is P. This is P. Now, this is 30 degrees, 90 degrees, 120 degrees. So, these two are equal. Opposite angles also equal. Opposite angles also equal. Then how much is obtained? Opposite angles. 30, 120, 120, remaining how much? 60. Then what you will get? 30, 30. 30, 30. Clear? If it is 30, this would be 90, 120, 120 plus 60, 180. So here, how to apply sine rule? How to apply sine rule? Apply sine rule. Apply sine rule. The magnitude of each side is proportional to the sine of the angle between other two sides. Clear? So once you apply the proportionality, what you will get? Tell me. This is O, this is P, this is how much? I. This is how much? I. So now tell me, IP by how much? IP by how much? IP by sine of the angle between other two sides. Okay, now what is the opposite angle for this particular side? 120, 120. Sine 120 will come here. Sine 120 will come here. After that, OP by sine how much? OP by sine how much? 30, 30. After that, OI, IO by opposite angle. IO by how much? Sine 30, sine 30. Lamis equation also similar. Lamis equation came from the sine rule. Lamis equation came from the sine rule. So now tell me, IP, I am interested in IP. Sine 120 how much? Root 3 by 2. Sine 120 is sine 60. That equal to OP. r by 120, r by 1 by 2, r by 1 by 2. Once we equate it, ip what is obtained? Root 3 r is obtained. Now tell me, what is the velocity at point P? What is the velocity at point P? Velocity at point P equal to product of angular velocity of the disk on which 2 points are present. Okay, now 2 points, we selected 2 points, both the points present on this particular disk. This is single disk problems only, single rigid body problems only in our syllabus. Okay, now combination of rigid bodies, that is pure BTech. Clear? So omega into how much? Distance between the given point and instantaneous center. Omega into how much? Omega into root 3r. Omega into root 3r. Root 3 into omega r. Omega r equal to v. Root 3v. Root 3v. So what is the velocity at point P? By using method 2. This is the velocity at point P, that equal to root 3v. Now we need to discuss one of the important topic, ladder problems. Ladder problem, kinematics. First we need to talk about kinematics in ladder question. Completed. So this is pure rolling analysis, kinematics of rolling by using vector approach. Kinematics in rolling by using instantaneous center method. How to apply this problem in ladder? This method in ladder. Check it once. All velocities are matching with the vector approach. Next slide up. Another case, ladder case. How to apply the same method for ladder? One of the popularly asked question in competitive exams. How to apply instantaneous center method for single link problem? Single link, single rigid body cases. Single rigid body case. Single rigid body. Ladder is the single rigid body. Here, see the figure. See the figure. This is the ladder. Ladder. Take the ladder. This is the ladder. Ladder. Here. So ladder. Okay. Ladder. So velocity, this would be point A. This would be point A. This would be point A. This would be point B. Okay, now. So here, this is how much given? 1 meter given. This is 45 degrees given. 45 degrees given. Okay, 45 or 30 doesn't matter. So that is 1 meter. 1 meter. Now, so here velocity at point B given as, or else velocity at point A or velocity at point B must be given in the question. Okay, now, so velocity at point B given as, velocity at point B given as 1 meter per second. 1 meter per second. Then they are asking, what is the velocity at point A? Then they are asking, velocity at point A equal to dash meter per second, and angular velocity of the ladder also asked in the question. Velocity of the ladder, this is the radians per second. Velocity, angular velocity of the ladder also asked in the question. Clear? So what is the first step in solving these kind of problems? What is the first step? చూడండి ఇక్కడ మనం ఏం చేసామో, దిస్ ఈస్ ద క్వశ్చన్. దిస్ ఈస్ ద క్వశ్చన్. Understood? So just draw the figure like this. చూడండి ఇక్కడ just draw the figure like this. మామూలుగా Here, this is A. This would be B. You can draw the line diagram. 90, 1 meter. This is 45. 45. This is the line diagram. Velocity at point B. Velocity at point B. Velocity at point B equal to 1 meter per second. Velocity at point A. Velocity at point A. VA is the velocity at point A. What is the first point? What is the first step? Tell me. What is the first step? Mark any 2 points on the rigid body. I marked 2 points on the rigid body. Understood? After that, draw perpendicular to those two. Draw velocity vectors. Draw perpendicular to those two velocity vectors. I have drawn perpendicular to those two velocity vectors. The point of intersection is marked as instantaneous center. So if it is 45, this is how much? If it is 45, this is how much? This is how much? 1 by root 2 meter. This is how much? 1 by root 2 meter. This is how much? 1 by root 2 meter. Are you following? 1 by root 2 sin 45 equal to IA by 1 meter. Understood? Now tell me, apply I center method. Apply I center method. Apply I center method. What is the velocity at point B? What is the velocity at point B? Angular velocity of the rigid body on which the 2 points are present, and product of angular velocity of the rigid body, distance between the given point, distance between the given point and instantaneous center, that is given as 1 meter per second. That is given as 1 meter per second. Clear? So now omega into how much? 1 by root 2 meter, that equal to 1 meter per second. Omega equal to root 2 radians per second. Root 2 radians per second. This is how much? Root 2 radians per second. Now, what is the velocity at point A? What is the velocity at point A? What is the velocity at point A? Apply instantaneous center. Same method. Coming to VA. Omega into distance between the given point and instantaneous center. Okay now, you can calculate velocity at any point on the rigid body, any point on the ladder by using instantaneous center method. That is the beauty of instantaneous center method. So that equal to how much? 1 by root 2. 1 by root 2. Sorry. Root 2 into root 2 radians per second into how much? 1 by root 2 meter. 1 by root 2 meter. Root 2 gets cancelled out. Finally, 1 meter per second will come. Velocity at point A. 1 meter per second is obtained for the angle 45 degrees. If they give 30 or 60 degrees, some other angle, you are in position to calculate. So here, what is the velocity at point A? Obtained 1 meter per second. This is how much is obtained. Root 2 radians per second. Now they are asking velocity at midpoint. Velocity at midpoint. So this is 0.5 meter. This is 0.5 meter. So if they are asking velocity at midpoint, IM, how to calculate IM? This is 45 degrees. 45 degrees. So what is this angle? Tell me. 45. This is also 45. This is 45. This is how much? 45. 45. Clear? So we can take the triangle. We can take the triangle. This is the triangle. From here to here. From here to here. This is I. This is M. Angle between the two sides we know 45 degrees 1 by root 2 meter, and this is 1 by 2 meter. So once you know two sides, okay na, and angle, you can apply cosine rule. Apply cosine rule. Apply cosine rule. Apply cosine rule. What is the cosine rule? Tell me. What is the cosine rule? Im square equal to how much? What is the Im square? Im square equal to how much? This is A. Sum of the two opposite. Sum of the square of the one side is difference between the sum of the squares of other two sides. Sum of the squares of other two sides. Difference between product of the two sides, 2 times of the product of the two sides, and cosine of the angle between other two sides. Clear? AM IA. Cosine of the angle between other two sides. Clear? So now tell me, AM square how much is obtained? AM square equal to how much? 1 by 2 whole square plus IA 1 by root 2 whole square minus 2 times of 1 by 2 1 by root 2 1 by root 2. Clear up? 2 gets cancelled out. 1 by 2 gets cancelled out. Then IM equal to how much is obtained? 1 by 2 is obtained. 1 by 2 is obtained. Actually, in the right angle isosceles triangle, this is also 45 degrees. Then these two must be equal. But you don't know, right? In other cases, 30 degrees and 60 degrees combination. You don't know that part. That is why we need to apply cosine rule. By using cosine rule, here I am. Understood or not? This root 2 gets cancelled out. 1 by root 2, 1 by 2 cancelled. I am equal to 1 by 2. Now tell me, apply eye-center method to calculate velocity at point M. M is the midpoint of the ladder. Angular velocity of the ladder into distance between the given point and instantaneous center. Clear? Omega into how much? What is the omega obtained here? Root 2 radians per second into how much? Im is nothing but 1 by 2 meter. 1 by 2 meter. That is equal to how much? 1 by root 2 meter per second. That is the velocity at midpoint of the ladder. Clear? Understood? Next right off. This part completed. Okay. This is what? Velocity at midpoint of the ladder. Velocity at this point of the ladder. So if they ask velocity at point P1, velocity at point P2, velocity at point P1 and P2, velocity at point P1 and P2, this BP is 0.25 meter. This is 0.25 meter. You can take 0.25 meter. 0.25 meter. Understood or not? Huh? This is right angle isosceles. 45 combination. These two must be same. Clear? So now tell me, if they are asking ratio between, what is the ratio between velocity at point P1 and velocity at point P2? Velocity at point P1 and P2. What is the ratio between velocity at point P1 and P2? So how to get it? Tell me. Here, this is how much? 1 by 4 meter. 1 by 4 meter. This is the point P1. This is the point P1. Are you following? Are you following? In case of M, this is P1. P1. In case of M, this would be P1. Same thing is obtained. Are you following or not? Take this triangle, place it here. Take this triangle, place it here. A P1I. A P1I. A P1 equal to 1 by 4. 1 by root 2 meter. Angle, included angle 45. So now tell me, A P1 square. This is I P1. This is I P1 square equal to how much? A P1 square is how much? 1 by 4. 1 by 4 whole square plus IA square how much? What is IA square? 1 by root 2 square. 1 by root 2 square minus 2 into 1 by 4 into 1 by root 2 into 1 by root 2 into 1 by root 2. Are you clear? There's 1 by root 2. Root 2 and 2 gets cancelled out. Here 1 by 16 plus 1 by 2 minus 1 by 4 minus 1 by 4 16. Here 1 plus 2 8 jar 4 jar. Finally how much you are getting? Finally how much you are getting? 8 minus 4 4 3 by 16. So 9 minus 4 5 5 by 16. So IP1 is how much? What is IP1? What is IP1 tell me? IP1 equal to how much? IP1 equal to how much? Root 5 by 4 meter. Are you getting the same? Check it once. AP1 1 by 4 whole square plus IA 1 by root 2 whole square 1 by 2. This is 16. 1 2 8 jar 4 4 jar 9 minus 4 5 by 16. 5 by 16. 5 by 16. Clear up. So now tell me what is the velocity at point P1? Angular velocity of the ladder into distance between the given point and instantaneous center. Distance between the given point and instantaneous center. That equal to how much? Omega how much? What is omega? Root 2. Root 2 radians per second into how much? Root 5 by 4 meter. So here P1 equal to how much? Square root of 10 by 16. How much is this? RS. Root 5 by 1 by 2. Root 5 by 2. Root 5 by 2 root 2 will come. 2 2 jar 2 root 2. Root 5 by 2 meter per second. Meter per second. So what is IP2? Tell me. What is IP2? 1 by 4. 1 by root 2. 45. This is how much? How to calculate IP2? How to calculate IP2? See this. This is I. This is I. Here to here B. Here to here B. This is how much? P2. P2 1 by 4 meter. 1 by 4 meter. If it is 45, here to here 45. So from here to here 1 by root 2 meter. So we need to calculate. IP2. Then IP2 is how much? Tell me. IP2. Then IP2. See this. IP2 square. IP2 square equal to how much is the time? Tell me. BP2 square plus IB square minus 2 times of BP2. 2 times of BP2 plus IB into cos 45. IB into cos 45. Are you getting the same? Are you getting the same? BP2 1 by 4. IB 1 by root 2. 1 by root 2. Of course same. Clear? Understood or not? Because it is what? This is what? Right angle isosceles triangle. Exactly mirror image you will get. Straight away you can I can say that both are having same velocities. I told you now, VB and VA also same velocity, right? VB and VA also same velocity because it is what? Right angled isosceles. Right angled isosceles triangle. So now tell me, what is BP2? Velocity at point P2 equal to how much? Omega into IP 2. So omega is how much? Root 2 radians per second. Root 2 radians per second into how much? IP2. IP2 is how much? Root 5 by 4 meter. IP2 how much is obtained? IP2 how much is obtained? Root 5 by 4 meter. So finally 1 by 2 times of root of 5 by 2 meter per second. That is the velocity at point P2. So this equal to how much? 1. This equal to how much? 1. The ratio between these two how much? 1. If I give velocity at point P1, P2, this is how much? Here to here. Velocity at point P3, P4. Okay now, this is how much? 0.125. Okay now, so in that case, what is the velocity at point P3 by P4? Velocity at point P3 by P4 equal to how much? 1. Velocity at point A and B equal to how much? Velocity at point A by velocity at point B equal to how much? 1. Understood or not? Because this is a right angled isosceles. Right angled isosceles. This is valid only for right angled isosceles triangle. If they give 30 and 60, we need to follow the procedure. Clear? Sine rule and cosine rule also covered here. Sine rule and cosine rule also completed.